Let's use what we know about chemical analysis to do a fairly complicated empirical formula example. So in this example, we have a blue-green salt, and we know it contains iron, chloride, and water. And we're going to do an analysis for iron. So this first part here is going to be an analysis to understand the amount of iron in our sample. And then we're going to do an analysis to figure out how much chlorine we have in our sample. And then we can find the water by difference, recognizing that the percent by mass of iron plus chloride plus water has to add up to 100%. So our plan of attack is going to be, first of all, to find percent mass iron, and then to find the percent mass chlorine from the data, and then find percent mass water by difference, and then use our percent mass of each of these to do an empirical formula problem. So step one, let's find the percent by mass iron. So to do that, we're going to use this first analysis in the problem. And we notice the very first thing is that it's a titration. So we're going to use what we know about titrations to determine the amount of iron in this sample. And we've titrated it with potassium permanganate. That's the titrant, because we know its concentration, and we know the volume of potassium nitrate or potassium permanganate that we've used to completely react with the iron. So the first thing we always have to ask ourselves is, what is the reaction that we're using to do this analysis? And we're told that each potassium permanganate reacts with 5 iron ions. And I don't really know the charge on those iron ions, so I'm just going to call it N+. And that obviously produces some products. I don't really care what those are, because what matters is the ratio between the titrant and the analyte. And I know that that is 1 to 5. So I know that my titrant has a concentration of 0.100 molar, and I know that I used 5.02 milliliters of that. And so I can calculate the number of moles of potassium permanganate that I used by taking concentration times volume, making sure that I change volume into liters. And when I do that, I find that I have 5.02 times 10 to the minus 4 moles of potassium permanganate that were used in this titration. So now what I need to do is I need to figure out what's the equivalent amount of iron for that number of moles of potassium permanganate. And so I'm going to use the stoichiometric coefficients to do that. So if I have 5.02 times 10 to the minus 4 moles of the potassium permanganate, and I know that each 1 mole of the potassium permanganate is equivalent to 5 moles of iron, I can multiply by 5, and I find that I have 2.51 times 10 to the minus 3 moles of iron that was in my original aliquot of the sample. So what I really want is percent by mass, and so I need to go from moles to mass, but I know how to do that because I know that I can just multiply by the molar mass of iron, which is 55.847 grams per mole, to find the number of grams of iron that I have in my sample, and I find that I have 0.140 grams of iron. Now, to find percent iron, percent by mass iron, I need the mass of iron that's in my sample, 0.140 grams of iron, and then I need the total mass of my compound that was used in this analysis. So now I need to think carefully about this. So I started with 2 grams of the sample, but that was dissolved in a whole 100 milliliters of water. And out of that 100 milliliters, I only took a quarter of it to do this analysis. So I only have a quarter of 2 grams that I used to find this amount of iron. So this amount of iron is contained in 1/4, 25 out of 100, of the 2 gram sample. And so I actually only used 2 divided by 4 equals 0.5 grams of sample. So this 0.14 grams of iron is in 0.5 grams total of my sample. And so the percent iron in this sample is 28.03% iron. Next, we're going to use the second analysis to find the amount of chloride in my sample. So in this analysis, we took another 25 milliliters of the original 100. So again, we're using 0.500 grams of the sample to do this analysis. And it's reacted with excess silver nitrate to precipitate the silver chloride. And so this is a gravimetric analysis. So I'm going to base my amount of chloride in this 0.5 grams of sample by figuring out how many grams of chlorine is in this 0.721 grams of the silver chloride that was produced by the precipitation reaction. So we need to know the molar mass of silver chloride, and silver chloride turns out to be have a molar mass of 143 grams per mole. So I can figure out the number of moles of silver chloride that I have, so 0.7210 grams divided by the 143 grams per mole for the silver chloride tells me that I have 5.04 times 10 to the minus 3 moles of silver chloride. And every silver chloride contains 1 chlorine, so I have the same number of moles of chlorine. So I have 5.04 times 10 to the minus 3 moles of chlorine. And so again, I want to get to percent by mass, so I need to multiply this by the molar mass of chlorine, 35.453 grams per mole of chlorine, to find the mass of chlorine, just chlorine, in my sample. And that turns out to be 0.1788 grams of chlorine. And that was contained, remember, in my 0.5 grams of sample. And so my percent chlorine is the 0.1788 grams of chlorine divided by a total mass that I used in this analysis of 0.5 grams times 100% gives me a percent chlorine of 35.8% chlorine. Now my next step, not quite my final step, but my next step is to find the percent by mass water. And the way to find that is to take the percent mass iron plus the percent mass chlorine and subtract that from 100 because the sample contains only iron, chlorine, and water, and so these percentages have to add up to 100. So if I take 100 minus 35.8 minus 28.03, I will get my percent by mass water, which is 36.2% water. So now I have all the components of my overall compound, which again contains iron, chloride, and water. So I have 28.03% iron, 35.8% chlorine, and 36.2% water. So my next step is to find the empirical formula. So to do that, I already have percent by mass of each of the components, so I just assume 100 grams. And if I have 100 grams of the compound, I have 28.03 grams of iron. I have 35.8 grams of chlorine, and I have 36.2 grams of water. And I want to get to moles, so I can find the smallest whole number ratio of moles, not mass. And so I need to divide each of these by their molar masses. So 55.847 grams per mole for the iron, divide by 35.453 grams per mole for the chlorine, and divide by 18.015 grams per mole for the water. And so I will end up with the number of moles in 100 grams of each of these, and I get 0.501 moles of iron, and I get 1.01 moles of chlorine, and 2.01 moles of water. And my next step would be to divide by the smallest number of moles, so 0.5 moles of iron. So if I divide everything by 0.5, be the same as multiplying everything by 2, I will find that this is 1 iron to 2 chlorines to 4 waters. And so I can write my empirical formula as iron to chloride, and this is a hydrate because the 4 waters hydrate this ionic compound, so I do dot 4H2O. And that provides me with the answer to my problem.